Welcome to part 2 of chapter 5, section 3, radical functions. The great thing about this chapter is we're finally starting to get to equations in Algebra 2 that are actually applicable, almost entirely applicable without changing them to problems in the real world. Now, granted, there's some upper level stuff in here. I mean, this is high school math. This isn't college level math that would be eventually factored in if you go into that field, but we get a good idea. So turn with me to page 254. We have to read the examples to go do the monitoring progress at the bottom of the page. So you might want to pause and read it yourself. One way or the other, though, you're going to listen to me summarize the problem. Okay. So for number 3, we got to look at example 3. Okay. So let's look at example 3. The function e of d is equal to 0.25 rad d. That approximates the number of seconds it takes a dropped object to fall d feet, so it's important to know what kind of number you're using, d feet on Earth. The function m of d is equal to 1.6 times e of d. Okay, so the function m of d, which is how long it takes for an object to fall d feet on Mars, is 1.6 times Earth, the function for Earth, okay? We want to approximate the number, write a rule for m. So we want to know like directly, instead of plugging it into Earth's equation, then multiplying by 1.6, is there a way we can just get the equation for Mars and then finally plug in 64? So why don't we just plug in 0.25 rad d where we see e of d? Okay, so there we go. I plugged it in, I wrote it in red. Now we can just do 1.6 times 0.25. So I did that on my calculator and I got 0.4. So the time it takes for an object to fall d feet on Mars is 0.4 rad d. Time it takes in seconds, that is. All right, so how long will it take for an object to fall 64 feet on Mars? Well, let's plug in 64. Notice I plug in 64 for d on the left and the right. And when I do that, I get about 3.2 seconds. I'm just using my calculator. Well, I did 0.4 times 8, which 8 times 4 is 32. There's one decimal point, move it over 1. 3.2 seconds. Okay, so now let's look at monitoring progress 3 at the bottom of the page. The function, and the one was red, n of d. So this is number 3 at the bottom of the page. So the function n of d, and that's how you say it, is equal to 2.4 e of d. And that's for how long it takes in seconds for it to fall d feet on the moon. Write a rule for n and then plug in 25. All right, so let's write a rule for n. So n of d is going to equal 2.4 times, what is e of d? 0.25 rad d. What's 2.4 times 0.25? It's 0.6. So n of d equals 0.6 rad d. Okay, so write a rule. I can now just tell you, if we take the square root of how far it's going, times it by 0.6, that's how long in seconds it takes for an object to fall d feet on the moon. So how long will it take for an object to fall 25 feet on the moon? Let's plug in 25. N of 25 is equal to 0.6 rad 25. 0.6 times 5, what's that? 6 times 5 is 30, and we have 1 decimal point, so it's going to be about 3 seconds. Or you can use a calculator. Okay, cool. All right, number 4, you can read it on your own. It's really all about the core concept on transformations, which we've done before, but we are getting a little tricky with them. So, all right, in example 4, is the transform function the same when you perform the translation by the horizontal, followed by the horizontal? Okay, so what are they doing in example 4? I guess we got to read it. Number 4. Number 4, example 4 first. I apologize. Example 4 first. Let the graph of G be a horizontal shrink by a 6th, followed by a translation 3 units to the left of the graph. Okay, so f of x is equal to cube root of x. We want to first do a horizontal shrink by a factor of 1/6. Okay, so if we remember correctly, when you do a horizontal shrink, you, instead of multiplying by 1/6, you multiply the x by 6/1, the reciprocal, right? Horizontal shrink by 1/6 looks like a stretch, but it's not. It's a horizontal shrink by a 6. And then it says followed by a translation 3 units to the left. Okay, so that means that we need to then make parentheses for the x, and 3 to the left. Left is towards the negative numbers, which means we write positive. Remember, left, right, horizontal, always do the opposite. And now that's not done. We can simplify this by distributing, and that's how, in example 4, they get this answer. Okay, now that's example 4. Question 4 is saying, what if it's reversed? We do the transformation first and then the horizontal shrink. All right, so number 4, we're going to do the transformation first. So cube root of, we don't need parentheses in this case because we're just going to move it 3 to the left. There's only an x right now. Okay, and then we do a I'm just double checking, followed by the horizontal shrink. It's a horizontal shrink of 1/6. However, whenever we do a stretch or a shrink, we only multiply the x. We only multiply the x. So it is 1/6, which means we just get 6x plus 3. Notice the difference, in fact, and go back to when that was confusing back in chapter 2, I think. Maybe 1, probably 2. Okay, all right. So a little bit on translations, which you could, use Desmos to help you out with, but you need to remember the order of how you apply things and where they go to. All right.